All right, lesson 4.4. So if you're just joining in, you can take a quick picture or whatever of all the bell ringers. There they all are, but I'm going to work through some of these one by one, and we'll get going on lesson 4.4. So as we have learned, starting with lesson 4.1 about trigonometry, the first shape that I gave you when we first started solving these type of problems were a triangle. And so this one's no different. I would solve it the same way. I would just create an x-axis and y-axis to help me visually get started. And this problem in particular says that we have an x value that's -5 and a y value that's positive 12. And so I would just go left 5 units. I'm just going to say that's left 5 for an x. And I would go up 12 on my y-axis. Let me label this properly, x and y. And so that's going to be where the terminal point would be located. So the problem says terminal point. So let's talk about what that means. Every angle has what we call an initial point, or initial side rather, which would be on the x-axis, and the terminal side is where the angle points to at the end. And so if I labeled this properly, you would put an angle symbol there, or theta. But for solving purposes, the way we've done this is we've solved this as a triangle. So I'm now going to switch colors here. Let's just go to green. And we would solve this as a triangle in this manner here. So is all that I'm doing required for you? No, I'm just kind of giving you an overview. And we would say, I'm going to use that as my right angle. And the theta I'm actually going to use is this one here. We learned last class you'd call that a reference angle. So technically you'd put a little tick mark on that, a little apostrophe. Theta prime there, that would be our reference angle. And we learned that you can solve with either theta and still get the same solution. But I'm going to solve this as a triangle. So I'm going to say my -5 is my x-axis value. My y value is 12. Hypotenuse goes there. We don't know what that is, other than by rule, hypotenuses are always positive. We can solve using the Pythagorean Theorem. And for that, I use x squared plus y squared equals h squared. All right, students, get ready for some mental math here. So my x is -5. My y is 12. I could use some help squaring that. What is -5 times -5?
25.
25, great. And 12 times 12?
144.
That's correct. Okay, so now we need to add those together. So 25 plus 144. $160 and
9.
There we go, 169. 169 equals h squared. And so mathematically, the opposite of a square, if you want to get rid of the square, you have to do the mathematical opposite. The opposite of a square is a square root. And normally in mathematics, we'd say anytime you apply a square root, you need to have plus or minus. But by rule, the hypotenuses are always positive. So this will be just 13. The square root of 169 is 13. So now that we know that value, we could find our trig functions like the problem asks us to do. Sine will be y over h. Cosine will be x over h. Tangent will be y over x. Psi y, cos x. Tangent is y over x. Cosecant, x h over y. Secant, h over x. And finally, cotangent is, whoops, not h. It will be x over y. So if we plug in our values here, y is 12, h is 13, x is -5, h is 13, y is 12, x is -5, h is 13, y is 12, h is 13, x is -5, and x is -5, h is 12. There would be your 6 answers. So most of that lesson was covered in 4.1 and then following. Really, the one thing that was different in 4.1 is we didn't deal with negatives, but negatives, as we learned in lesson 4.3, just means you go the direction left. If it's a negative x, let me rephrase. If it was a negative y, you would go down. Okay, so number 2 deals with finding cosine 3 pi. And honestly, I did this in a bad order. So in the future, if you're watching this might be number 5 in the future. But for me right now, today, it's number 3. So I ask you to find cotangent 3 pi. And so you can look on our unit circle. That's what we call this over here, the unit circle, for 3 pi. The problem is you won't find a 3 pi. So we'd have to find a coterminal. So coterminal is when you either add or subtract a full revolution, which would mean either, since this is in radians, you'd add or subtract 2 pi, or if you're dealing with degrees, you would add or subtract 360. So since 3 pi is not on there, I see 1 pi right here. I see 0 and 2 pi. I don't know where 3 pi is. Well, I'm going to pretend like I don't know. What would you do? Well, you could do the coterminal. You say, well, 3 pi is going to be equal to, if I subtract 2 pi, 1 pi. 3 pi minus 2 pi is 1 pi. And we could call this these coterminal angles. Coterminal. Now, what does that mean if they're coterminal? Well, coterminal, like I was just saying in the previous problem, terminal means the ending side. These two angles would share the same ending side. Pi would be equivalent to 3 pi there. And so we also learned in lesson 4.3 on example 8 that if we have coterminal angles, since our trig functions are periodic, cotangent of 3 pi would be equal to the cotangent of 1 pi. I don't know why I put those in parentheses. They did not. I'll add a parentheses there. Now it's all the same. Okay, so all I need to find is what is the cotangent at pi. And so from the previous slide, cotangent's x over y. And so I go over here and I say, that's my point right there. I'm going to have x divided by y, which again, every point comes in the form x comma y. Or you could throw on an h on there, but whoops, I put x over y. I meant to put -1 over y value of 0. Math, are we allowed to divide by 0? Are we allowed to divide by 0?
No.
No. So this one would be an undefined, because you cannot divide by 0. That would be our solution here. Cotangent 3 pi is undefined. I guess let me write out the full English. Okay, so that's number 2. Let's take a look at number 3. It says find the value of cosecant 210 degrees. So in a unit circle, what you do is this. You find 210, which is right here. So this value along this gives us our values. Now, when the points are giving us fractions, it's easier, rather than to think of them like the previous problem where I said x comma y. If they're giving us fractions, it's easier to think of this as x divided by h and y divided by h. It'll be much quicker for solving, especially when you're finding cosecant, because cosecant is h divided by y, which means, started to actually write the word cosecant. Let me just write the symbols. CSC, 210 degrees would equal, from over here, I can tell you that my x is -√3, my y is -1, and my h is 2. So I could just say this is 2 over -1, or -2. That would be my solution. Okay, now I'm going to slow down on this problem before I move on. I'm going to spend a little more time explaining this. So now I know that my answer. How did I get that? Well, if you think now in terms of a triangle, I'll try to make sense out of this. 210 degrees is the angle from the positive x-axis over. That's the angle 210. For this triangle, we have gone 30 degrees past 180, or the nearest x-axis, said another way. So we would call this a reference angle of 30 degrees. On a 30 degree, 30, 60, 90, which was what this becomes, because that's 90 right there, We have 30 in this corner. That leaves us with 60 for the other corner. We learned earlier that the side lengths come in a value of 1, square root 3, and 2, where the hypotenuse is the 2, the shortest leg is 1, and the medium leg is square root 3. See lesson 4.1 on that. Okay, special right triangles. Well, where do the negatives come from? Because the x value is going left, you would list that as a negative. Because the y value is going down, this would be a negative. And thus, I have a y here of -1, which matches up with this -1. I have an x here of negative square root 3, which matches up, and a hypotenuse here, which matches up with my hypotenuse. And these values, if you forgot, came from this point. So that is, right there in a nutshell, how you connect the unit circle, this unit circle, to a triangle. The unit circle finds triangles on the special right triangle values on the 30, 60, 90s, the 45, 45, 90s, and it does it in every quadrant. That's what it is. All these values are 30, 60s, 90s, or 45, 45, 90s, but listed in different quadrants. That's in a nutshell what the unit circle is. So hopefully that connects a little extra information for you so that you can kind of sink in your brain how that works. So let's see it. I think I have 3 more of these to let you see it 3 more times. So it says find the exact value of cosine 2 pi over 3. Let me blow this up for us, make it easier to see here. Okay, cosine 2 pi over 3. Well, and one more thing on the unit circle. So we always know points are listed as x, y. I said it's for the fraction values, it's easier almost to think of it as x divided by h and y divided by h. Well, we know x divided by h is cosine, y divided by h is sine. So you can also think of it this way. So if I find 2 pi over 3, which I have right here on this line, the cosine is just simply the front value, the value before the comma. That would be cosine. This one would be the sine. So the answer in this one would be -1/2. Without spending as much time tying it together, but trying to do so just in a very brief portion, the reason x is negative is because you go left. This would also be a 30, 60, 90 triangle. So the shortest side would be the 1, medium side, square root 3, hypotenuse is 2. Since I'm left, that's the negative. So cosine is x over h, thus it's -1/2. It's just the unit circle does that a whole lot faster than drawing the triangle. Okay, number 5, tangent 13 pi over 6. So let's look around the circle for 13 pi over 6. I see a pi over 6 there, but that's not it. I see 5 pi over 6, that's not it. 7 pi over 6, that's not it. There's 11 pi over 6. None of those are it. So if it's not on there, we have to use coterminal angles. So 13 pi over 6. What I'll do is I'll subtract 2 pi because 13 is just bigger than what I have. If I do this, I'll use Desmos. Desmos is great for finding this. By the way, I'm about to connect what you're looking at with what we're doing today. 13 pi over 6. So I'm going to do 13 over 6, no pi's, minus 2, representing 2 pi. Gives me that crazy decimal. If you hit the fraction line, it tells you as a fraction, this is the same as 1 over 6. So this is 1 over 6. Since I did not type in the pi's, I'll now write it up there. It's equivalent to 1 pi over 6. We just found that 13 pi over 6 is equivalent to 1 pi over 6, or I should say coterminal. That's proper vocabulary. Because tangent is periodic, that means tangent of 13 pi over 6 will be equal to tangent of its coterminal pi over 6 value. And I'll simplify there and just write pi over 6. So I can go to pi over 6, which I see it there. Sine is y, cosine's x, tangent is y over x. And so here's my y is 1. Here's my x, square root of 3. This is 1 over square root 3. All right, question for you. I'm going to involve the classroom now. We're not supposed to submit an answer with a square root in the denominator. How do I rationalize the denominator? What's the trick I've taught you?
Move it up.
Push it up.
There you go. So we push it up. And so we have 1 square root of 3 over, and what goes on the bottom now?
3.
3.
Just 3. Yeah. And if I simplified this, I get square root of 3 over 3. By the way, all these values I've done so far, you could check with Desmos, but Desmos won't give you as a square root. So you could type in here and go to functions, tangent 13 pi divided by 6. Let me make sure I'm in radians. I am, good. I checked it by hitting that wrench in the top right hand corner. And then we could check our answer, square root 3 divided by 3. Since the decimals match, we did it correctly. Okay, so that's just a check. And last one, number 6. It says sine is -1/2. I want to remind you. Actually, I want to take a break. Do you want me to solve this first using the unit circle? Or would you rather me do the algebra first and then use the unit circle? Which way would you like me to do this first? All right, here, algebra first in the chat. I say here, I read. Okay, so sine is y over h. Sine is y over h. That's its ratio. So sine, that means y is -1, h is 2. Because remember, h is always positive. We're told cosine is less than 0. Well, cosine is x over h. We know h is always positive, which means when I solve for x here, x is being divided by h. How do you get rid of division?
Multiplication.
Multiply. If I multiply both sides by h here, since h is a positive number, we don't change the inequality. Remember, it's an old inequality rule. If you multiply by a negative, you need to flip the direction. But this one's going to stay the same direction because we know h has to be positive. And honestly, h is 2. So I could have even written that in, that h is 2, multiplied both sides by 2. We get that x is less than 0. So that means x is negative. What you can do now is draw a triangle and solve from there. And I'm going to let you do that on your own. Y's got to be negative. X has to be negative. So it should be a triangle. Y goes down 1 unit. X, we don't know where it is, but we do know it's negative. And so our triangle might look something like this. But we know we have a negative, whoops, we know what not y is. Y is -1. We know that value is -1. We know this is a negative x, and we know we have a positive h. I know what h is, sorry. H is 2. Let me write that in. H is 2. And you could do Pythagorean theorem. I said I was going to solve it with algebra. I'm going to lie. I was hoping you'd say, let's use unit circle because this is how easy it is now. Once you discover that x is negative, that means if you're looking at the unit circle, we're not going to look over here. X has to be negative. We also learned y is negative, which means we're not going to look up top. Y is -1. So all we have to do is find where sine is -1/2 in the third quadrant. We established it has to be in quadrant 3 because x and y are negative. So sine is the y. This is the spot right there. That's sine. So we found the spot, which means I can get all my values from there. Let me just write them out here for you next to it. My x is -√3. My y is -1. My h is 2. I got that all from this point right there. Since that is -1/2, I just use that. Okay, so to find our trig functions, sine was -1/2. We already were told that. Cosine would be -√3/2 because it's x over h. tangent is y over x. So negative 1 over negative square root 3. I'll reduce that in a little bit. CSC would be negative 2 when you flip, negative 2 over 1. Secant will be 2 over negative square root 3. And then cotangent is going to be square root 3 over 1. Both of these negative. Okay, so let's reduce these. Tangent, 2 negatives, and I got to shoot that up. 2 negatives make a positive, so this will be square root of 3 over 3. This one becomes negative 2. I have to shoot that up. So 2 square roots of 3 over negative 3. And then this one, 2 negatives becomes a positive, and dividing by 1 leaves it. That would be the value there. So there you have it, 25 minutes worth of overview of lesson 4.2, 4.3, all of them combined, really, because we did some triangles too. That's your introduction there. 25 minutes well spent, though, hopefully, going over all these major topics. All right, before I get going, I'm going to show you where we're going, and then I'll walk you through. So we're going to be looking at the graph. Now, I want you, there's 2 graphs going on in this separate. I know it looks like one graph sitting there, but I want you to separate it as 2 different graphs. What I want you to notice is that I have a red circle, which I've labeled unit circle. Now, if I were at working on my computer at school, I had it sized where it looked perfect. This one's stretched out. I'm on an iPad here. As I record this, DISD canceled school. We're teaching remotely, so I'm at home on my iPad, and it doesn't look like a perfect circle. But for my work computer, this would have come through looking like a perfect circle like it's supposed to. I had it sized right for the screen. On the right side, you had the graph of sine, which we're going to learn about today, the sine wave. Sine and cosines, when you graph them, y equals sine or y equals cosine, they appear as a wave. Now, I want to connect these two things together. On the left side of the screen, the red graph, the unit circle, remember, sine deals with y. The blue graph is just the graph of sine, y equals sine. So what should happen as I start to make this graph move? Any point on the blue graph should match the exact same height as the height on the red circle. Now, here's the reason. Because on the unit circle, sine is y. Remember, sine is y. And on the blue graph, we have y equals sine. So the values should always have the exact same height because the y values are sine on both of these. So notice as I go around the wave and the unit circle, they produce the same height. Okay, so now if sine is y, let's go back. We start at a height of 0 because y, the y-axis right there, we're on the positive x-axis, but y is 0 there. If I go up to its maximum, we've learned in radians, and if you look on the left side of your screen, it's pi over 2. When I get to pi over 2, which is hard for me to do with my finger here, if I get to pi over 2, I'm at the maximum of the graph. It's a height of 1. The maximum on this graph is 1. If I go around to the value of pi, I'm at, notice I'm cutting through the x-axis again because y is 0 again at the radian pi. If I go to 3 pi over 2, 3 pi over 2 produces the minimum. Now let me connect one more time the unit circle to the blue graph on the right. The unit circle on the outside is showing your radian. The blue graph, the radians are what's labeling the x-axis. So that spot's not labeled there, but other than it says on the right side that the point is 4.7. 4.7 is 3 pi divided by 2. That's where that 4.7 comes from. So this is connecting the unit circle to sine. Pretty neat, isn't it? Let me just press play here. You can see all the values as they work themselves out. The y's would always be the same. If you could follow that point as quickly as it's moving, the y values are always equal to one another. Pretty neat, isn't it? Please say yes. I spent a lot of time working on this. Okay, now I'm going to show you cosine. Cosine's a little bit different. Cosine's a wave as well, But cosine will start at its maximum. Why? Because on the unit circle, if you think about the unit circle, oops, I didn't mean to click that point. On a unit circle, we start at x's radius of 1, and the x-axis is already at its maximum. So that's why we graph it as y equals cosine, what's going to change is the cosine value is on the blue graph. If you look at this point on the blue graph over here, it has a value of 1. That's because what I had to type in to graph it is y equals cosine. So even though cosine usually represents x, on the blue graph, it's going to be, the cosine is going to be placed in the y quadrant. Whereas if you look at the point down almost directly below it, you'll see it's 1, 0, because on the unit circle, it's x, y. So when I press play on this one, they don't seem to match up. Though technically, everything is cooperating. Everything's working correctly. I have worked this out. This is working. That's the way it's supposed to look. It looks strange. What would fix it? Well, what would fix it is if somehow on the unit circle, we could swap our x and y axis, or almost rotate it like this. Whoa, here I go. Let me rotate the x and y axis. If I rotated the x and y axis, now you would see that it would function just properly, because now on the unit circle, you're looking at the x-axis being the vertical axis, and on the graph on the right, you're seeing the cosine going through. So this now works properly. One more thing. This is pretty neat, I think. Let me take the shift out of this so that the graphs are right on top of each other. Well, it's not really shifting. Come on, go back over. When you see them on top of each other, now you can look at how the graphs start compared to how they conclude. You can see how they start exactly the same, but because the red's making a circle and the other one's making a wave, they deviate from there. So I hope that intrigues you. I hope that builds a little interest for what we're learning today. All right, so here we go. Lesson 4.4, graphing. Here's the equations. I need you to write these down so you have them. Both equations, it doesn't matter if it's sine or cosine, come from this form. Okay, so write these down. And then I'm going to write down some little notes here where A is amplitude. They have different names. And then I'm going to connect the names to what we've already known in the past. Where A is amplitude, B is used for the period. Can I shift this? Yes. And frequency. C is used for the phase shift. And D is the vertical shift. So notice the words I wrote down. I wrote vertical shift, phase shift, frequency, amplitude. Sinusoid is all this is, sine or cosine graph with transformations. That's all it is. Okay, a midline is just the middle of the graph. It's like the x-axis. It's the middle graph. Okay, so there's your notes. I'm going to go jump through this a little bit faster than you're probably used to because I'm going to try to combine these transformations together. You remember transformation rules. Let me now draw a little line here. Transformation rules I'll write over here because they still apply. The rules have not changed. The rules we had earlier this year, rule number 1 was HIVO. That horizontal will be inside, vertical will be outside. Horizontal inside, vertical outside. So A and D are verticals. Letters A and D, while letters B and C will be horizontal. Okay, and then rule number 2 is that inside lies, outside tells the truth. Okay, so with those notes, let's go through this. And I want to go, like I said, a little bit faster than normal. Just bear with me as you see these transformations, because I'm going to be, unfortunately, I'm going to use both language, and I'm probably not going to use the same order all day, just because I'm going to mess up, lack of better terms. But the words are going to be the same. Amplitude, old school, what we would have called this first semester, amplitude, we might have called this vertical stretch or shrink. Okay, so these are the words I might exchange. I might, instead of saying amplitude when I want to say amplitude, I might say vertical stretch or shrink. Those mean the same thing. Period or frequency is going to, specifically I'll talk about the period, or the B will calculate the horizontal stretch or shrink. Though they're not the same. So amplitude is the vertical stretch or shrink. Horizontal stretch or shrink isn't the period though. That one's a little different. We'll get to that in a second. Phase shift is normally just a horizontal shift, and D is vertical shift. That one is its own same word. So phase shift is the same thing as a horizontal shift. Okay, so now with all that, let's look through some of these examples. Down at the bottom of the page, they show you the two graphs, which I just showed you a second ago. You might have realized they were both waves. The difference is, key note here, that sine goes through the point 0, 0. Sine without a transformation goes through the origin, goes through 0, 0, whereas cosine starts at its maximum. It starts at 0, 1. Sine and cosine, without a transformation, their maximum value is a height of 1, or the amplitude is 1. It means it goes up to a height of 1. The midline is the x-axis, which means it has a minimum of -1. The amplitude is 1 because the maximum and minimums are just the absolute, or whatever the absolute value is 1. Period, here it is shown at the bottom of the screen, means how long does it take for one full cycle to go from maximum to maximum, minimum to minimum, or from midline up through the maximum through the minimum back to the midline. That's a period. Okay, so now let's start with amplitude. If you were looking for amplitude, what you would do is you would look at the maximum heights and compare it to the midline. So on this problem, this amplitude on this first graph here is an amplitude of 1. Now that little blue graph is the graph F. So the blue one is F here. I don't know where to write it other than there. The blue is F. Now how do I know the amplitude is 1? If I look at the equation, it's F equals sine x, which is the same thing as 1 sine x. So that value of A, the value that comes in front of the sine, or cosine for that matter, is your value A. That is your amplitude. Okay, on graph G, which is green, the equation up above is 2.5 sine x. Now, I'm not going to read through the whole problems today, because a lot of this is just, it's the same exact instructions. And for the sake of time, I think it will be better for you, for me to show you more examples than to read the whole set of words each time around. So this is the A, which means for graph, the screen graph, the amplitude equals 2.5. Now let me point out what that 2.5 does not mean. What it does not mean is it does not mean that it goes up to 1.25 and down to 1.25, double it, you get 2.5. That's not what it means. It means from the midline, so from the x-axis to the top, you get a height of 2.5, which would also mean from the midline down to the bottom, you would have a total distance of 2.5, but it's going downward. So distance we normally calculate as positive, And so amplitude means it goes up 2.5 and down 2.5. Okay, so I just don't want you to get, that's one of the things that a lot of students get confused on there, but that would be the amplitude. 2 periods, it says sketch 2 periods. What makes this 2 periods is a period's calculated when, if you start here at the midline, we do one whole, or we go up to one maximum, back to the midline, do a minimum, back to a midline. That would be a period. So from here to there is 1 period. That's 1 full cycle. Midline to max, max to min, min to midline. Midline to maximum, max to this minimum, and back to the midline. That's a period. This graph has 2 periods. That's 1 period. This would be a second period. Okay. So on the first one, I use the word amplitude. And I told you before I even started that I'm going to just unfortunately mix up and use the wrong words when I'm not intending to. So let's just say I unintentionally, but even though I did, let's just say I unintentionally only use the word amplitude. Now we come to this problem and you're looking at your DOL and you realize, oh no, it says nothing about amplitude. Well, what you need to remember is that the amplitude from the notes that I gave you before we started is the same thing as a vertical, stretch, or shrink. If the number is bigger than 1, it's a stretch. If it's less than 1, so stretch is greater than 1, shrink is less than 1. So stretch if it's greater than 1, shrink then less than 1. So on this problem, it's on the outside. So would that make it a, let me do rule number 1. If the numbers are on the outside, does that make it vertical or horizontal?
Vertical.
Vertical. So we could eliminate 2 options based off of that. And then if the number is bigger than 1, we're talking about G here. The number is bigger than 1, it's a stretch. Or I guess here they're using words expanded or compression. So expanded would be a stretch, compression would be a shrink. If the number is greater than 1, it's an expansion. If it's less than 1, it's a shrink. That should be enough time for you to get an answer. If you want to put it in the chat, make sure you send it to the co-host account. Okay, I'm going to move on. So use your 2 transformation rules. I'm just to wrap this up one more time. This lesson really ties in a couple different pieces of information. It connects vocabulary, and the transformation. So here's the vocab. You need to know the vocabulary, and you also need to know your transformation rules. Okay, so if you need to take a screen capture of this, do so. Let's take a look at example 2. Example 2 now. We have a negative in the front. So this time I need to use red. Graph of f is in red. And I'm going to put it as 1 cosine x. And so what's different about cosine is it's going to start at its maximum point. It's going to start at 0, 1. This is the graph f. Okay. Now what happens? Oh, let me write out this rest. That means our amplitude is 1. It'll go up 1 and it'll go down to -1 from the midline. Now blue is going to represent G. G is graphed in blue. So this will be my graph G. Notice it goes down to -2 and it goes up to +2. This one goes, the maximums and minimums will be at 2s rather than at 1s. Okay, so G of x is -2 cos x, which means the amplitude, now get this, the amplitude is 2. You don't say the amplitude is -2. What the negative is if you've forgotten, the negative refers to a reflection. It's more specifically a vertical reflection. And vertical means that you flip your y values from up high to down low. So what was up goes down. Here's a perfect example. And so you go over the x-axis. It's tricky here because we think vertical was y, and that's true. Vertical does mean y. But when you talk about what is it reflecting over, it's crossing over a vertical reflection. I could say it this way, dot, dot, crosses over the x-axis. So that's what you'd be looking for there. That's why the amplitude is still a +2 and not a -2. So amplitude always just measures the distance from the midline to the max or the midline to the minimum. So that would be your two different transformations here. Again, one period you can measure. If I'm looking at this, let's look at the graph in blue. One period, we could say that starts at its minimum. And so I could go from minimum through the maximum back to the minimum. That would be one period there, one period. From minimum to minimum would be a period. And so this would be, to this point, a second period. So that's how the graphs work with each other. All right, let's look at this one. I'm gonna give you just a few seconds here. So we have f of x and you're comparing that to g of x. So you need to determine, is it inside or outside? Because that'll tell you if it's a vertical or horizontal type of transformation. And then secondly, when you deal with reflections, the reflection's very tricky, that if it's a vertical reflection, that actually means it crosses over the x-axis. If it's a horizontal reflection, then it crosses over the y. So that will help you get your answer here. I'll give you just a few seconds. All right, let's take a look at example 3. So now let's talk about period. So I told you period is not exactly the same thing as a horizontal stretch or shrink. That's because period isn't exactly equal to the b value. So the b value does affect your period, but period actually has its own formula. So without a transformation, one period is 2 pi. So said another way, if you just had the graph y equals sine x, in this particular case, your b value is 1. And so your period would be 2 pi divided by 1, which is 2 pi. So the standard period for sine and cosine is 2 pi. That means without a transformation, the period will take 2 pi. If you get a b value, then you divide it by your b. And they put absolute value here. And just to say, the period we always list it as a positive value because we're talking about like the amount of time, and you never list it as a negative. So no matter what your value is, just take the positive of it. So let me show you some of these. We're going to look at the graph of cosine versus cosine x over 8. So I'm looking on my graph, and the blue is f. And I'm going to put this in parentheses so you can tell that's the inside. So here's what we know this means. The amplitude is 1. Since the b equals 1, the period would equal 2 pi divided by 1, which equals 2 pi. Okay, all that we can determine for the blue graph. So that means to complete a whole cycle, you would need to go 2 pi. So from this spot to the next completed cycle, which means through the midline, down to the minimum, through the midline, back to the maximum, that would be 2 pi in distance. That distance right there would be 2 pi. Thus, when you look at the x-axis, this spot, it's hard to see that they're listing that as 4 pi right here. That would be another 2 pi. So 2 pi plus 2 pi is 4 pi. That's why the blue has a period of 2 pi. So now let's take a look at the red. The red graph is G. And I'm going to rewrite this as 1 cos 1/8 x this way, because you'll see it both ways here. I want to make sure you're prepared for either way you see it. So here's what this means. The amplitude is 1 because the amplitude is the front a value. The b is 1/8, which means the period would equal 2 pi divided by 1/8. Now I'll type that in Desmos, but the way it works when you have a fraction divided by a fraction is you take the reciprocal of the second fraction and then multiply. So 2 pi divided by 1/8. I'm not going to type in the pi. So I have 2 pi divided by 1/8. To make sure I don't mess up, put 1/8 in parentheses here. 2 pi divided by 1/8 is 16. Like I said, you would take the second fraction, take its reciprocal, then multiply. So it becomes 8/1. So it's 2 times 8/1. That's another way of doing it. 2, gosh, I did it again. 2 times 8/1, like that. And that's why it's 16. And since I did not type in the pi, that means my period is actually 16 pi. Okay, so on the red graph, 1 period is from this spot all the way to this spot. 1 period equals 16 pi for the red graph. That's from maximum through the midline to the minimum, through back to the midline to the maximum. It took 16 pi. Now this graph, it looks crazy because of how they scrunched it together. So now we'll go back over to my graph. I'm just going to get a new graph real quick. New graph. I'll type in, it was y equaled cosine x. And then the other, x. The other was y equals cosine x divided by 8. And as you see, you can't even see that whole thing. So I'm going to change the x-axis to go to 16 pi, and I'll just add 1 so you can see just beyond it, plus 1. There we go. So you can see for the blue graph to make 1 full cycle, the red makes 8 full cycles. If I thought I might put up the points for the maximum. That makes 8 full cycles. How do I know it's 8? Well, because remember the rule, inside lies. And so instead of dividing by 8, it multiplies by 8. So this one makes 8 full cycles. The red makes 8 full cycles before the blue makes 1 on its own. That would be the math. That's how I knew it was 8. It's because that number there was 8. Okay, back over here. Let's give you one. I want you to determine how these two graphs are compared to one another. So f is sine x, g is sine of 4x. And so this time I did it unintentionally. I mentioned at the start, I might use the words amplitude, period, stuff like that, but you need to know how to convert it to transformations, that terminology that we used first semester. So you need to be looking at if it's inside or outside, and then if inside lies or if it tells the truth, if outside lies or does it tell the truth. That's how you'll get your answer this time. All right, so let's now take a look at frequency. So frequency is simply stated, the easiest way to think about frequency is that it is the reciprocal of a period. So I know it looks like, well, wait, this is how you write reciprocal 1 over period, but basically it says it makes 1 cycle per period. But a lot of times the numbers themselves will work out to where it's not 1 over, say, 2 pi. A lot of times it might be 3 cycles per 2 pi or something like that. It just depends on what your b value is. But the formula is the same as b over 2 pi. And again, you would only take the positive b values. You want it counted as it has negative cycles. You just say positive cycles. So here's an example. A bass tuba can hit a note with a frequency of 50 cycles per second and an amplitude of 0.75. Write an equation for the cosine function that could be used to solve this model. To model this initial behavior of the sound wave associated with the note. Okay, so let's start with the basics. Here's what I know about basics. The sinusoidal function, that's the name for cosine with its transformations. Base model looks like this. They told us specifically amplitude is 0.75. That is always your A. Okay, so we got that part of the answer. They also mentioned we have a frequency of 50 cycles per second, or 50 hertz. So the formula for frequency is 1 over the period, or if you don't know what the period is, which we don't here, you can say it's b over 2 pi. And so that's the formula I'm going to use this time, is I'm going to say that b over 2 pi, I'll just go a little darker, b over 2 pi is going to equal 50, because that's my frequency. So now I need to mathematically solve for my b value here. How do you get rid of dividing by 2 pi? What's the opposite of dividing by 2 pi?
Multiplying.
Yeah, we multiply both sides by 2 pi. To keep good solid numbers, I'm just going to say that b is 100 pi, or around 314. That's all the information they give us, and we haven't learned about shifts yet, so we'll just say the equation is going to be y equals 0.75 cosine. The b goes first in the parentheses, so 100 pi times your x. That would be my equation. So we have no shifts, and so therefore there's no c or d. I'll just kind of mark those out since there's no shifts. Okay, so here's one again for you to try. All right, let's talk about shifting. So a horizontal shift is also called a phase shift. The one thing that's a little tricky on this one is by habit, we think of the C itself being the shift, but it's actually a combination of the B and the C. If there is a B value, you have to factor that in. Thus, we get this value. What's wrong on theirs is you do not take the absolute value. If B is negative, that plays into account. So the phase shift is negative C divided by B. That is your phase shift formula. If I could change that from the book, I would, but I can't change their slide, so I just have to scribble it out. So now let's look at this problem. We're going to write out all the pieces. So remember, this is your A, B, C, and D would be out here. So D would equal 0 right now because it's just not there. Okay, so amplitude. Amplitude is your A, which is 2. So that means this graph goes up to a highest value of 2. That's the maximum. And the minimum would be at negative 2. Okay, next, let's do period. So I just did amplitude. So now let's go on to period. The period has a formula that it's 2 pi divided by b, where you only take the absolute value of b. And so in this particular case, it would be 2 pi divided by 5. I can't simplify that, so that's our period. Frequency has 2 formulas. You can either say b over 2 pi, or you can just say it's the reciprocal of the period. Since I know what the period is, I'm going to write it out that way. So it'll be 5 cycles per 2 pi. That's what frequency means. For every 2 pi, this would make 5 full cycles. And thus we've done frequency. And that leaves us with phase shift. The phase shift is negative c divided by b, which in this particular case would be negative pi over 4 divided by 5. So I'm going to type this in the calculator in Desmos. I'm not going to use the pi symbol. I'm actually just going to put in, and I'll do it in as, let's see, fraction. The numerator, since it's 2 fractions, I'll put it in parentheses. Negative 1 pi divided by 4. I'm going to write it like that. And then we divide that by 5. As a fraction, that's negative 1 over 20. So now I'll include the pi. It'll be negative 1 pi over 20. Negative pi over 20. That's my phase shift. And so that's the graph. It looks, so sine is supposed to go through the origin. So originally it would go through 0, 0. As you can see, this has been shifted a little bit left because of the phase shift. Okay. So there's all the separate pieces that we've learned so far. So now I have one for you, and I'm just going to label it for you. This is your A. Your B is 1/3. The reason I'm going to write this one out is because it's a little bit harder than what I did. So your B is 1/3. This is your C. And since there's nothing out there, that the D is 0. Now you go ahead and take a shot. All right. So now let's look at vertical shift. So this is probably the easiest because it doesn't change the name. So if I went through this again, let's say, go in order. The amplitude is the A, which in this problem, you can't really see a number, so I'll put 1 there. You can't see a B, so I'll put 1 there. This would be C, that's my D. Amplitude A is 1. My phase shift, or excuse me, that's amplitude. My period, let me go in order. I don't like that color green, let me switch. The period followed the formula 2 pi divided by B. So it'd be 2 pi divided by 1, which is simply 2 pi. So the period hasn't changed. My frequency is the reciprocal of the period. You could either say B over 2 pi, or you could just say 1 over the period. The reciprocal, which on this one would be 1 over 2 pi. The phase shift follows the formula negative C divided by your B. So in this particular problem, it's a negative pi divided by 1, which is simply negative pi. So this has been shifted left pi units. So if it normally starts, sine normally starts at 0, 0. This is a sine graph. This, the red graph, has been shifted left 1 pi. So wherever 1 pi is, this part of the graph should be going through at negative pi. That's what that tells you. Okay, and now let's do vertical shift. Vertical shift is just the D. So this graph goes up 1 unit. So as you can see, the midline is no longer the x-axis. The midline is now at 1, and it has a height of 2, and it drops as low as 0. So the amplitude is still 1, but it goes from the midline of 1 up 1 to 2, and it goes down 1 to get to 0. All right, here's another one for you to try. So this one, there's a trick if you just look at the vertical shift and the amplitude. If you go off the vertical shift first, it should eliminate a couple answers, and then you can eliminate from the amplitude to have your final answer. All right, now let's take a look at, so here's the equations I gave you at the very start. And all the formulas right there. What I did not tell you, I guess, is the midline is the vertical shift. That's one thing I did not tell you on there. Okay, you can use Desmos Calculator for figuring these things out. This one, I'm not going to be able to go back and forth from my iPad and type all these values in, but I do have a Desmos Calculator for this. So hang on 1 second. Okay, so if you go to the classwork and then you go to Desmos pre-programmed graphs, this is a regression problem. Let me blow this up. This is a regression problem, so it's graph number 6. If I click that, I should be able to get the answer to this problem. So the x's are the days in our problem, and I'm sorry, I can't go back and forth today. It's just the way it is. So it starts at 1 day, and then it goes to 2, and then 3, and then 4, and then after, I think if I just keep it in, it goes all the way to day 30. So there's 30 days. So I open up that regression calculator, and so now I need to type in my values. So day 1 was 25.9. Day 2 is 25.8. Day 3 is 25.6. See if it'll be easier to do it this way. Oops. 25.3 is day 4. 25.1. 25. I lost it. Where am I at? Day 6. 24.7. And you know what? I'm going to just stop for a second and go down to sinusoidal. I wonder if I don't even need to type in all these points. I'm going to go here and type that in. So see, it's already coming up with an equation for me. And it's saying it's really, really accurate. If r squared equals 1, it's perfect. So I'm looking over here and I'm taking down my value. So what I'm now going to do, let me switch back over to my iPad. I'm going to write down these values though. So right here, these are the same values. And I'm going to switch back over to my iPad. And I can write out the equation. So the equation was y equals, the a was, I'm going to round it to the nearest hundredth. So I'll round 4.95 sine. My b is 0.11. My c was 1.65. And my d was 21.05. Kind of ran out of space there. Let me slide that over just a tad. Now you get the full value. So that was from Desmos regressions. And that's how I got that value. So that's how you can write a trig function using calculator data. So you see the picture on the right, how it does represent a trig function. It's like a wave. Okay, so here's one that you can try on your own. You can just pause this or whatever. Okay, finally, let's finish up this lesson. How might this look on the ACP? So it says the graph of y equals cosine is shown on the domain from 0 to 2 pi. It says if the domain was extended to negative 2 pi, determine 4 other points that would lie within the left side of the domain. Hint, from negative 2 pi to 0. Okay, so what I'm going to do here is first, I'll extend my graph. Let me actually see if I can slide this over a little bit. And I'm going to extend my graph this way. And so this wave, if it continued on, will go down, round, and back up. Now, I'm not the best artist, so my apologies there. We have to find 4 other points. What I would recommend finding, we'll call this one 0.1, 0.2, 0.3, and 0.4. And these will model the same points from the opposite side, just a reflection. So this is on the graph y equals cosine x, which means this is the x-axis. So this value right here is an x. The y value is 0, which means point number 1 would be the reflection of this. This x-axis value would be, I'll write it beneath it. This would be negative pi over 2 comma 0. That would be point number 1. Point number 2 would represent this one there. So this is kind of like 1. This will be point number 2. Its x-axis value is shown to be pi, and its y value is negative 1. So point number 2, this value right here, must be negative pi. So it would be at negative pi, comma negative 1. Point number 3 would correspond, we're losing it over there, but it'll be at 3 pi over 2. I'll tell you this right now. At that point would be at negative 3 pi over 2, 0, negative 3 pi over 2, comma 0. Now, how do I know that? Because this function, it's consistent, and it goes from negative pi over 2 to 1 pi to negative 3 pi over 2. That's how it counts. And then finally, the last value will be at 2 pi. This one, if we went down, is negative 2 pi. As the domain says, that's how far it extends. So the value would be negative pi over 2, comma 1. Those would be 4 points located here. Okay, with that, I don't know if I can actually, on my iPad, I wish I could just shrink it. I'm not sure if you can do that, but that would be the 4 points and how I would solve it here.